For decades, our attention has been fixed on this: Mars, the red planet. We have sent rovers, landers, and orbiters. We've analyzed its soil, studied its ancient riverbeds, and marveled at its blue sunsets. And the entire multi-billion-dollar question we've been asking is, was there ever life on Mars? We are in effect searching a cold, dead planet for fossils. We are archaeologists digging for the ghosts of life that may have existed 3 billion years ago. But what if we've been pointing our cameras at the wrong target? What if the greatest discovery in human history isn't a fossil, but a living specimen? What if the most likely place to find living extraterrestrial life isn't a planet at all, but a tiny, ice-covered moon almost 500 million miles away? Today, we are opening the case file on the prime suspect in the search for active alien life. Forget Mars. We are going to Europa. Case file: Europa. Location: 484 million miles from the Sun, orbiting the gas giant Jupiter. Size: slightly smaller than Earth's moon. Appearance: a sphere of brilliant white and reddish-brown ice, covered in vast intersecting cracks. When the Voyager probes first flew by in 1979, we expected to see another dead, crater-pocked world like our own moon. Instead, we saw this. The surface of Europa was smooth, bafflingly smooth. It was almost completely missing the one thing every old dead world has: impact craters. This lack of craters meant one thing: the surface was young. Something was actively wiping the slate clean, resurfacing the moon like a cosmic Zamboni. Then, as the Galileo probe gave us a closer look in the 1990s, we saw how. The surface is not a solid, static shell. It is a mosaic of giant, broken icebergs. We can see places where the ice has cracked apart, drifted, and then frozen back together in new positions. This is not a geological theory. This is a photograph. Scientists call it chaos terrain. We have a more familiar name for it on Earth: Arctic ice sheets. The photos from Europa looked eerily like satellite images of the Arctic Ocean. And that led to the single most electrifying hypothesis in modern astronomy. The only way these massive ice rafts could float and move is if there was a liquid layer beneath them. The evidence was pointing to a vast, hidden, global ocean. To build a case for life, we need 3 key pieces of evidence: the holy trinity of astrobiology: liquid water, a stable source of energy, and the right chemical ingredients: CHNOPS, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Mars fails on the first 2. Europa might have all 3. The chaos terrain was a strong clue, but we needed definitive proof. And the Galileo probe found it, not with a camera, but with a magnetometer. As Galileo flew past Europa, it measured Jupiter's colossal magnetic field. But it also detected a second, weaker magnetic field, centered inside Europa itself. This new field was bizarre. It was flickering and changing, perfectly in sync with Jupiter's own field. There was only one explanation. This was an induced magnetic field. Here's how it works. Jupiter's powerful magnetism was sweeping through Europa, and as it did, it was inducing an electrical current inside the moon. That current, in turn, was generating its own magnetic field. For this to happen, Europa must contain a global, spherical layer of something highly electrically conductive, like a salty ocean. The case was blown wide open. The models based on this data are staggering. Beneath an ice shell, estimated to be 10 to 15 miles thick, lies a liquid, saltwater ocean. This ocean is not a small, isolated sea. It is global, and it is deep. Estimates range from 60 to 100 miles deep. Let me put that in perspective. The average depth of Earth's oceans is 2.5 miles. The deepest point, the Mariana Trench, is 7 miles down. Europa's ocean, a moon smaller than our own, contains twice as much liquid water as all of planet Earth combined. We had found the water. But in the cold, dark outer solar system, why wasn't it frozen solid?
Europa is too far from the sun to be warmed by its light. The surface temperature is minus 260 degrees Fahrenheit. The energy source, it turns out, is Jupiter itself. This is tidal heating. Europa is locked in a constant gravitational tug of war. The immense gravity of Jupiter pulls it, squeezing the moon. But Europa is also pulled by its sister moons, Io and Ganymede, in a perfect orbital resonance. This cosmic alignment means Europa's orbit is not a perfect circle. It's slightly eccentric. So as it orbits, it gets closer to Jupiter, then further away. With every 3.5-day orbit, the entire moon is squeezed, relaxed, squeezed, relaxed. This constant flexing, like bending a metal coat hanger back and forth, generates an incredible amount of friction and heat deep within Europa's rocky core. That heat is the engine. It radiates up from the core, keeping the 100-mile deep ocean in a permanent liquid state, perfectly insulated by the 15-mile thick ice shell above. This engine doesn't just provide warmth, it likely creates the single most important feature for life: energy.
A deep, inquisitive, and intelligent documentary tone. The voice should be like a detective or investigative journalist, starting with a familiar scene, Mars, and then pivoting to a new, more compelling suspect. The tone is one of building excitement and overwhelming evidence. If Europa's rocky core is being heated by tidal friction, then its seafloor is almost certainly volcanic. This would create hydrothermal vents, and on Earth, hydrothermal vents are factories for life. In 1977, when scientists first dove to the mid-ocean ridges, they expected to find a desert. Instead, they found the most densely populated ecosystem on the planet. Black smokers gushing superheated water rich in chemicals like sulfur. And living off this chemical soup with zero sunlight was an entire food web. Giant tube worms, pale crabs, and trillions of microbes. They were not powered by photosynthesis. They were powered by chemosynthesis. They were eating chemicals. This discovery proved that life does not need the sun. It only needs water, energy, and chemicals. Europa provides all three. We also have an analog for the ice shell, Lake Vostok, Antarctica. This is a massive liquid freshwater lake buried under 2.3 miles of solid Antarctic ice. It has been sealed off from the surface for over 15 million years. When scientists finally drilled into it, they found it was teeming with thousands of species of bacteria. Life had found a way in the total, crushing dark. Europa is simply Lake Vostok on a planetary scale. So, we have the water and the energy. What about the food, the chemical ingredients? The hydrothermal vents on the sea floor would provide the building blocks: sulfur, phosphorus, minerals. But the real trick is oxygen. Life as we know it needs an oxidant, something that readily accepts electrons, like oxygen, to power metabolism. Europa's surface provides it. Jupiter's magnetic field is a particle accelerator, trapping and slinging high-energy radiation.
This radiation constantly slams into Europa's ice shell. This process, called radiolysis, splits the water ice, H2O, into hydrogen, which escapes to space, and oxygen. The surface of Europa is, quite literally, being infused with oxygen and other powerful oxidants. But how does it get to the ocean, 15 miles below? The chaos terrain. The ice shell is not static. It is a conveyor belt. The ice surface, rich in oxygen, gets broken up, and the slabs are slowly churned and pushed down into the ocean, while clean ocean water freezes to the bottom of the shell. This ice tectonics could be the lungs of Europa, delivering life-giving oxygen from the surface to the dark liquid realm below. The case was almost perfect. We had the ocean, we had the engine, we had the food. All we were missing was a confession. In 2012, the Hubble Space Telescope was pointed at Europa, looking for something else entirely. What it saw changed the future of space exploration. It captured this: a faint, hazy plume erupting from Europa's southern hemisphere, shooting 125 miles into space. It was a geyser of water vapor. The ocean was leaking. This was the smoking gun. This was the suspect caught in the act. The immense pressure of the ocean, combined with the tidal squeezing, is apparently cracking the ice shell and blasting the ocean's contents directly into space. The implications are breathtaking. For decades, the biggest challenge was, how do we get to the ocean? How do we drill through 15 miles of ice that is as hard as granite and as cold as liquid nitrogen? The answer, it seems, is we don't have to. Europa is offering us a free sample. We don't need a drill, we need a bucket. We can simply fly a spacecraft through one of these plumes, collect the frozen particles, and analyze them on the spot. We can, quite literally, taste Europa's alien ocean.
This discovery led directly to this, the Europa Clipper. This is NASA's next flagship mission, launched in 2024 on a direct course for Jupiter. This is our search warrant. The Clipper is not designed to find life. It is designed with forensic precision to confirm habitability. It is here to close the case. It will fly by Europa 44 times, some as low as 16 miles above the ice. Its mission? Confirm the ocean. It has an ice-penetrating radar. It will scan the shell, measure its exact thickness, and confirm, once and for all, the depth and saltiness of the liquid ocean beneath. Analyze the chemicals. It has a mass spectrometer. It will fly through the plumes and directly sample the particles, tasting the ocean. It will be looking for salts, organic molecules, and the CHNOPS building blocks. Find the hot spots. It has a thermal imager. It will scan the surface for unusual hot spots, places where the ice is thinnest or where warm ocean water is actively melting the shell. The Europa Clipper is not a life finder. It is a life searcher. It is the reconnaissance mission that will tell us where to land. It will map the X on the treasure map for a future mission, a lander that will one day drill into that ice and drop a submarine into an alien sea. So, why is Europa the prime suspect? Mars is a fossil, a cold case, a planet that might have had microbes 3 billion years ago. Europa is a living, breathing crime scene. It has more liquid water than Earth. It has an active internal energy source, tidal heating, that is more reliable than our sun. It has a chemical factory, hydrothermal vents, on its sea floor. And it has a delivery system, plumes, that is spraying the evidence into space for us to find. On Earth, we have found this combination of water, energy, and chemicals. We have found life. Every single time. The case file is clear. If we are going to find living extraterrestrial life in our solar system, it is not on the red, dusty plains of Mars. It is almost certainly swimming in the dark, warm, 100-mile deep ocean of Europa.